Hi, this is Mr. Woodbury from College of the Sequoias. This is for my Math 21 class. We're covering Section 11.1, the two proportion test. We'll go over the background information for this test, try a couple of examples, and then we'll talk about an alternative test to do when the conditions are not satisfied. The two proportion test is used to compare the proportion of one population that has a certain trait to the proportion of a second population with a certain trait. For example, we can test that the proportion of COS students who own an iPhone is the same as the proportion of students at Reedley College that own an iPhone. Here we're comparing one population to another rather than one population to a number, like the proportion of COS students who own an iPhone is 30%. Now we're comparing the students at COS to the students at Reedley College. When we identify this test, we're going to look for two sets of sample information of the form X out of N. This many out of that many. The data will be qualitative or categorical, not numerical or quantitative. Think about the question you would ask, like, do you own an iPhone? And the kind of answers you would get, yes or no. Those are categories. That means that we're dealing with proportions, not with means. Finally, the two populations will be compared to each other rather than one being compared to a percent, like I mentioned above. We're comparing students from two different schools rather than comparing students from one school to a particular number. Here are the differences from the one proportion test. First, you have to identify which population will be population number one. This is important because the order of the sign for H1 depends on which group is population 1. You must do this for every test that comes from Chapter 11, the two sample tests. That includes Section 11.2, the pair difference test, or Section 11.3, the two mean test. Once you establish which population is population 1, the null hypothesis will always be of the form P1 equals P2. Now in StatCrunch, that's going to look like this. P1 minus P2 equals 0. They focus on the difference between the proportions. The way we write it, we're just saying that they're the same. Whatever you do, do not change the 0 in the null hypothesis for this test. The alternative hypothesis will either have a less than sign, a greater than sign, or a not equal to sign between the two symbols. And again, this comes from the wording in the problem. No differences in step 2. For step 3, the only difference is now we'll write the two proportion test. For the calculations in step 4, we go to stat, proportion stats, to sample with summary. As I mentioned, leave the value for P1 minus P2 as 0 and pick the appropriate sign for H1, or what StatCrunch calls HA. Now, before we actually do the calculations, there are conditions that need to be checked. And these are similar to the one proportion test, except we repeat it for each sample. For the first sample, we have to make sure that n times p hat sub 1 times 1 minus p hat sub 1 is greater than or equal to 10. So that's that bell-shaped curve condition that we've been doing. We do it with p hat because we don't have a value to use for p1. Then make sure that the first sample size is no more than 5% of the first population size. Then we can repeat that for the second sample and population as well. Let's take a look at an example. In a random sample of 150 college students, 15 were smokers. In a random sample of 144 adults with a high school diploma or less, 34 were smokers. At the 0.01 level of significance, test the claim that college graduates are less likely to be smokers than adults that did not attend college. We begin by identifying population 1, and the safest way to do this is not by just automatically going with the sample that showed up first. Take a look at the claim you're testing. Here, it's that college graduates are less likely to be smokers than adults that did not attend college. The first group mentioned in the claim should be listed as population 1 because at that rate, we can use the wording to tell us about our sign. So for population 1, we'll call that college graduates. For the null hypothesis, remember that's going to be P1 equals P2. For the alternate hypothesis, we're going to have to put the correct sign between P1 and P2. And again, here it says that college graduates are less likely than adults that did not attend college. P1 is less than P2. For the level of significance, we're given alpha equals 0.01. Now for the test, it looks like a two proportion test, but we have to check those conditions. If it's not, we'll call this two proportion randomization, and we'll talk about that later. For the conditions, for sample 1, first we check that n sub 1 times p hat sub 1 times 1 minus that sample proportion is greater than or equal to 10. N is 150. The first sample proportion is 15 out of 150. 1 minus that will be 135 out of 150. And this will give us the exact value. 150 times 15 divide by 150 times 135 divide by 150. That will give us the result. Now we can approximate this by converting those two numbers to decimals. 15 divided by 150 is 0.1, and 1 minus 0.1 is 0.9. When we multiply that out, we get 13.5, which is greater than or equal to 10. For the 20N condition, making sure the sample size is no more than 5% of the population size, 20 times 150 is 3,000 college grads. Are there more than 3,000 college grads? Yes, there are. So both conditions are met for sample 1. We'll do the same thing for sample 2. N sub 2 times the second sample proportion times 1 minus the second sample proportion. The sample size there is 144. For P sub 2, the sample proportion, that's 34 divided by 144. 1 minus P hat sub 2 is 110 minus 144. And by the way, that 110 is just 144 minus 34. To 3 decimal places, this works out to be 25.972, which is greater than or equal to 10, so that condition is met. Finally, 20 times the second sample size is 20 times 144, or 2,880 people with a high school diploma or less. Are there more than 2,880 people with a high school diploma or less? Yes, there are. So both conditions here are met. That means that we can do the test. Let's go to StatCrunch. Keep in mind that the first sample proportion is 15 out of 150. The second sample proportion is 34 out of 144. Also keep in mind the sign for H1. P1 is less than P2. Let's go to StatCrunch. Since we've already verified the conditions for this two proportion test, we begin by pressing Stat, Proportion Stats, to Sample with Summary. The first population was college graduates. That sample was 15 out of 150. For the second sample, 34 out of 144. For the hypothesis test, we leave this as P1 minus P2 is equal to 0. That's equivalent to the way we write the null hypothesis, P1 equals P2. The correct sign here would be less than. The first proportion is less than the second proportion. Press compute, and there are the results. The z-stat is negative 3.13, the p-value 0.0009. The test statistic we found was negative 3.13. The p-value was 0.0009. That is less than the level of significance. So that means that we reject the null hypothesis. Low p-value means we reject HO, and that means that there is sufficient evidence to conclude that H1 is true. Let's write that in words. There is sufficient evidence to conclude that college graduates are less likely to be smokers than adults that did not attend college. Example 2. A survey of 415 kindergarten children who lived in the suburbs revealed that 24 had been diagnosed with asthma. A survey of 638 inner-city kindergarten children revealed that 69 had been diagnosed with asthma. At the 0.01 level of significance, test the claim that inner-city children are more likely to have asthma than children who live in the suburbs. Okay, we're comparing one population, inner-city children, to a second population, children who live in the suburbs, and we're comparing proportions. More likely is like a probability, and that's a type of proportion. Also notice we have two sets of this many out of that many, x out of n, 24 out of 415 for kids in the suburbs, 69 out of 638 for kids who live in the inner city. Everything here points to a proportion test. Population 1, I'm choosing inner city children, because that is mentioned first in the claim, not kids who live in the suburbs. Even though up above, information is given for kids who live in the suburbs before kids who live in the inner city, the claim is talking about inner city children compared to children in the suburbs. We should let inner city children be population 1. The null hypothesis is P1 equals P2. What sign will we use for the alternative hypothesis? The claim is that inner city children are more likely. P1 is greater than P2. If you let the kids from the suburbs be population 1, you would have to change that sign around. Saying the kids in the inner city are more likely also means that saying that the kids who live in the suburbs are less likely, and you would have to change the sign. It's always safer to go with the order of the claim. The level of significance given in the problem as 0.01, and again, this looks like a two proportion test, but we have to check the conditions. Working first with the kids from the inner city, we're going to multiply the sample size by the sample proportion by 1 minus the sample proportion. The sample size is 638. The sample proportion is 69 divided by 638. 1 minus that is 569 divided by 638. Rather than estimating those as decimals, this will give me the exact condition. However, if I rounded these to, say, 2 place decimals, I would find that the condition's clearly true. But in my lab, you're going to be asked to do this exactly to 3 decimal places. We want to be careful how we do that. I get 61.538 for this, and that is definitely greater than or equal to 10. For the 20 times n condition, 20 times 638 is 12,760 inner city children. We know that the population is definitely larger than that. For the second sample, talking about the kids from the suburbs, again, we'll multiply the sample size by the sample proportion by 1 minus the sample proportion. The second sample size is 415. The second sample proportion is 24 over 415, and that leaves us with 391 out of 415 for the complement of that. By the way, when we go to multiply these out, notice the 415 in front will cancel with one of the 415s in the denominator. All we have to really do is multiply 24 by 391 and divide that result by 415. I get 22.612, again, much bigger than 10. So that condition is met. 20 times the second sample size is 20 times 415. That is 8,300 kids from the suburbs. And we know there are more than that as well. So we can go on and do this as a two proportion test. Let's go to StatCrunch. Again, we need to know the first sample proportion, 69 out of 638. We also need to know the second sample proportion, which was the 24 out of 415. And we do need to make note of the sign in the alternative hypothesis. H1, and that's a greater than sign. Let's go to StatCrunch. Okay, since we've already verified the conditions for this two proportion test, begin with stat, proportion stats, two sample with summary. The first sample was for the inner city kids. That sample was 69 out of 638. The second sample was 24 out of 415. Again, leave the null hypothesis as equal to 0. And because inner city kids are our first population, and that's supposed to be greater than for kids from the suburbs, we'll use greater than. Press compute. And there are the results. The z-stat, 2.81, with a p-value of 0.0025. Okay, we found that z was equal to 2.81. That means that our sample results were about 2.81 standard deviations higher than we expected if the two population proportions were equal. The p-value was 0.0025. So now we need to make a decision about the null hypothesis. And again, we compare this to the level of significance. Is 0.0025 less than 0.01? It is. Now, some students at the beginning have trouble seeing that. I think a good idea is to rewrite the level of significance using 4 decimal places. Now we're really comparing 25 to 100, and we can see that it's definitely less than the level of significance. So we're going to reject the null hypothesis, and that means that there is sufficient evidence to conclude that H1 is true. In this problem, that means that inner city children are more likely to have asthma than children who live in the suburbs. In the decision, we rejected HO. In other words, we rejected the idea that the two proportions were the same. And in the conclusion, that means that we were able to support the idea that inner city children are more likely to have asthma than children who live in the suburbs. So we've essentially thrown our support behind H1 being true. Okay, now we'll move on to the two proportion randomization test. This is a test we use when the conditions are not all satisfied. Let's go over this test. So again, if any of the conditions fail, we can perform this test by using the randomization test for two proportions. The changes for writing up the test, steps 1 and 2 are the same. For step 3, we add randomization to the end of the name of the test. So it's the two proportion randomization test. In step 4, there's no test statistic that we'll write. We'll just compute a p-value using the steps shown below, and that is the last step that's different. In StatCrunch, if you click on Applets, Resampling, Randomization Test for two proportions, or by the way, you could click on StatCrunch first and then the same menu items. We'll use the radio button that comes for From Summary. Then we'll fill in the boxes for the sample data in the same way that we filled in the two proportion test. Press Compute to create the applet, and then we'll press the button labeled 1,000 times, 10 different times, to run the simulation 10,000 times. What's basically happening here is the StatCrunch applet is taking all of the responses and reshuffling them into the two samples. And we're trying to note how often we observe a sample difference as large or larger than the sample difference we saw in the problem. If it's a left-tailed test, the p-value is going to be in the below row. For a right-tailed test, it will be in the above row. And if you have a two-tailed test, it will be in the total row. Let's get started with an example. Example 3. Test the claim that the proportion of COS students who are female is greater than the proportion of Fresno State students who are female at the 0.05 level of significance. A random sample of 40 COS students had 24 female students, 60%, while another random sample of 60 Fresno State students had 30 female students, which is 50%. This looks like a two proportion test. We're testing a claim that the proportion of one population is being compared to the proportion of a second population. We have two sets of sample proportion data, 24 out of 40 at COS, 30 out of 60 at Fresno State. Everything here points to this being a two proportion test. Population 1 will be the COS students because they are mentioned first in the claim. Test the claim that the proportion of COS students who are female is greater than the proportion at Fresno State who are. The null hypothesis is that P1 is equal to P2. What sign will we use for the alternate hypothesis? We're going to use greater than because the claim is that the proportion of COS students who are female is greater than the proportion of Fresno State students who are female. The level of significance is given in the problem as alpha equals 0.05, and this appears to be a two-proportion test. We still have to check the conditions. If the conditions fail, then we will switch out to the two-proportion randomization test. Let's check the conditions for COS first. To do that, we'll multiply the first sample size by the first sample proportion by the complement of the first sample proportion, and that result has to be 10 or greater to move on. The first sample size at COS is 40 students. Multiplied by the first sample proportion, which is 24 out of 40, as a decimal, that's equal to 0.6. So I'm going to have 40 times 0.6 times 1 minus 0.6, that is 0.4. If I multiply 40 by 0.6 by 0.4, I get 9.6. This is not greater than or equal to 10. The conditions fail, and so we're going to perform the two-proportion randomization test. When we go to StatCrunch, we need to know the two sample proportions. The first, again, is 24 out of 40. The second, at Fresno State, that is 30 out of 60. And we need to know what tail the test is. In H1, we're using the greater than sign, so this is a right tail test. Let's go to StatCrunch and compute that p-value. Since the conditions fail for the two-proportion test, we can do the randomization test by clicking on StatCrunch, Applets, Resampling, Randomization Test for two proportions. Rather than gathering our data from a data table, we're going from summary. Sample 1, the number of successes was 24 out of 40. That was for COS. And I'm just going to label that as COS. For sample 2, the number of successes was 30 out of 60, and that was at Fresno State. So I'm going to label that as Fresno. Click Compute. And this will build the applet that we need. And we want to run this 10,000 times. So I'm going to press 1,000 times, 10 different times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10,000 times that we've drawn a randomized sample of these two proportions. Because the alternative hypothesis was P1 is greater than P2, we'll use the row that says 0.1 or above. Now, 0.1 is the difference between the two samples, 60% versus 50%. That's a difference of 0.10. And that's counting all the times that COS resamples to be higher than 10% above Fresno State. And we see that that happens 0.229 or 22.9% of the time. That 0.229 is our p-value for this test. Now, because these are randomized, your results are going to differ slightly, but they still should produce the same conclusion. I found a p-value to be 0.229. Your results will vary slightly because this is a random process. However, we should all end up with the same decision here, and that is fail to reject HO because the p-value is not lower than the level of significance. When we fail to reject HO, that means there is not enough evidence to conclude that H1 is true. In this problem, that means that there is not sufficient evidence to conclude that the proportion of COS students who are female is greater than the proportion of Fresno State students who are female. Failing to reject HO means that we can't say the null hypothesis is false. In our conclusion, that means that we cannot say that we had the evidence to prove that the proportion is higher at COS than Fresno State. One quick big picture note here. Notice that the sample proportion at COS was 60%, while at Fresno State it was only 50%. That's a difference of 10%, and that seems like a pretty big difference. However, it is not significantly larger. It generated a p-value that was much too high to be conclusive. So even though the samples are off by 10%, that is not enough evidence in this case to prove that the proportion's higher at the first school, COS, than it is at the second school, Fresno State. Okay, now for one more example, example 4. A company is developing a new drug to lower a person's cholesterol. A doctor claims that there is no difference between the performance of this new drug and the performance of a placebo. A random sample of 100 people used the new drug for 6 months, and 70 of them reported that their cholesterol was lowered. Another random sample of 37 people used a placebo for 6 months, and 19 of them reported that their cholesterol was lowered. Test the doctor's claim that there is no difference between the success rates for the new drug and the placebo at the 0.05 level of significance. Population 1 will be the new drug because that is mentioned first in the claim, that the success rates for the new drug and the placebo have no difference. The null hypothesis is P1 equals P2. What is the correct sign to use in H1? The claim is that there is no difference. No difference means that they're the same, not that one is higher or one is lower. When that is the case, the alternative hypothesis or the alternate hypothesis is not equal to. So P1 not equal to P2. The level of significance given in the problem, alpha equals 0.05, and at first glance, this looks like a 2 proportion test. Now, if all of the conditions are satisfied, that is the way we'll do the test. Let's begin with the conditions for the new drug. And I'm going to begin with the sample size multiplied by the sample proportion multiplied by its complement for the first sample, the new drug. The sample size is 100. The first proportion that for the sample is 70 out of 100, which divides evenly to be 0.7. So we've got 100 times 0.7 times 0.3. That equals 21, and that is large enough. The next condition to check for the new drug is the sample size can be no more than 5% of the population size. And we check that by multiplying 20 times the sample size and making sure that that's smaller than the population size. 20 times 100 is 2,000 cholesterol patients. Are there more than 2,000 cholesterol patients? Yes, there are. So both conditions are met for the first population and its sample, the new drug. Let's move on to check the conditions for the placebo. We'll begin again by multiplying the sample size by the sample proportion by the complement of the sample proportion. Here, the second sample proportion is 19 over 37. Now that does not divide out evenly to be a decimal, so I'm going to do the exact calculation. The sample size is 37. The sample proportion is 19 out of 37. And 1 minus that will give us 18 out of 37. And that comes from subtracting 37 minus the 19 that did report lower cholesterol. When we multiply these, remember that we can divide out a 37 in the numerator and the denominator, and we're left with 19 times 18 divided by 37. That computes to be 9.243, rounded to 3 decimal places. That is not greater than or equal to 10. Therefore, the condition fails. And we're going to have to do the 2 proportion randomization test. Let's go to StatCrunch for the calculations. Again, the first sample proportion is 70 out of 100, the second 19 out of 37, and we're working with a two-tailed test. H1 is P1 not equal to P2. Let's go to StatCrunch. Again, since the conditions failed, we can do the randomization test by clicking on StatCrunch, Applets, Resampling, Randomization Test for two proportions. Again, go down to where it says From Summary, select that. Sample 1 was for the new drug, and the number of successes was 70 out of a sample size of 100, and I'm going to label that as new drug. For the second sample that came from the placebo, that sample was 19 out of 37. I'll label that as placebo. And let's build the applet by clicking on Compute. Again, we're going to run this 10,000 times. The row that we're interested in is the total row. That includes both differences that show up in the left tail or the right tail, because this is a two-tail test. 10 times we'll press the 1,000 times button. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I look to the total row, and the proportion that's in that total row is 0.046. That is the p-value for this problem. Now, this is close to 0.05, so randomly you may end up with a slightly different decision than the one I'm about to put on the screen. Okay, my p-value was 0.046. Since that is less than the level of significance, we will reject the null hypothesis. That means that we're saying that the null hypothesis is false. That also means that there is sufficient evidence to conclude that H1 is true. In other words, we can conclude that there is a difference in success rates for the new drug and the placebo. When H1 involves not equal to, that means that we're concluding that there's a difference between the two, not that they are the same.